In 2022, there were three scientists: Alain Aspect, John F. Clauser, and Anton Zeilinger from France, America, and Austria received the prize for experiments with entangled photons. We shall learn about them, one by one. But first, let's see what they have achieved. The prize has been awarded for experiments with entangled photons, establishing the violation of Bell inequalities and pioneering quantum information science. But what did these inequalities actually say? They are a set of mathematical inequalities that constrain the possible results of certain experiments in quantum mechanics. If an experiment violates these inequalities, it means that quantum mechanics is non-local, meaning that information can be transmitted between two distant particles faster than the speed of light. In simple terms, Bell inequalities can be explained by a thought experiment. Imagine that you have two boxes, A and B, each containing a ball. The balls are either red or blue, but you don't know which color they are. You send one box to A and the other box to B, which are located far apart. They are each asked to open their box and look at the ball. They are then asked to report the color of the ball to you. You can then compare their answers to see if they match. If the balls are completely independent of each other, then you would expect that their answers would match only 50% of the time. However, Bell showed that if quantum mechanics is correct, then you would expect that the answers would match more than 50% of the time. This is because the balls in the boxes can be entangled. Entanglement is a phenomenon where two particles are linked together in such a way that they share the same fate, even if they are separated by a large distance. If the balls are entangled, then their answers will always match, even if they are located far apart. This is because if A looks at his ball and sees that it is red, then he knows that B's ball must also be red, even if he hasn't looked at it yet. Bell inequalities are a way to test whether or not quantum mechanics is correct. If an experiment violates it, then it means that quantum mechanics is non-local, meaning that information can be transmitted between two distant particles faster than the speed of light. Several experiments have been conducted to test these inequalities, and all of them have violated them. This means that quantum mechanics is non-local, and that information can be transmitted between two distant particles faster than the speed of light. Let us meet the architects now. First, we have Alain Aspect. He is a French physicist who is best known for his experiments on quantum entanglement. Detailed video on the same has been linked in the description below. Aspect's experiments provided strong evidence for the reality of quantum entanglement, and they helped to pave the way for the development of quantum computing and other quantum technologies. He was born in Agen, France in 1947. He studied physics at the École Polytechnique and the École Normale Supérieure de Paris. He received his PhD in physics from the University of Paris-Sud in 1983. His doctoral thesis focused on the development of new experimental techniques for studying quantum entanglement. After completing his PhD, he worked as a postdoctoral researcher at the University of California, Berkeley. In 1981, he and his colleagues conducted a series of experiments that provided strong evidence for the reality of quantum entanglement. In their experiments, they used entangled photons to test Bell's inequalities. The results of the experiments showed that the inequalities were violated, which provided strong evidence for the reality of quantum entanglement. Aspect's work has had a profound impact on our understanding of quantum mechanics. It has also helped to pave the way for the development of quantum computing and other quantum technologies. He is also a strong advocate for science education and outreach. He has given numerous public lectures and interviews about his work, and written several popular science articles, and is also a member of the board of directors of the European Physical Society. His work on quantum entanglement has revolutionized our understanding of quantum mechanics, and it has helped to pave the way for the development of quantum computing and other quantum technologies. Secondly, John F. Clauser. He is an American physicist who is also known for his work on quantum entanglement that has helped to prove its existence, and it has also paved the way for the development of new quantum technologies such as quantum computers and quantum cryptography. Clauser was born in Pasadena, California in 1942. He studied physics at the California Institute of Technology, Caltech, where he received his bachelor's degree in 1964. He then went on to Columbia University, where he received his PhD in physics in 1966. His doctoral thesis focused on the development of new experimental methods for testing the predictions of quantum mechanics. After completing his PhD, he worked as a postdoctoral researcher at the University of California, Berkeley. In 1972, Clauser and his colleagues published a paper in Physical Review Letters that proved the existence of quantum entanglement. This experiment is now known as the Clauser-Horn-Shimony-Holt experiment. He has also made significant contributions to the development of quantum teleportation and quantum cryptography. Quantum teleportation is a technique that allows information to be transmitted between two distant locations without being physically transmitted, while quantum cryptography is a technique that uses quantum mechanics to create secure communication channels. Clauser, too, is a strong advocate for science education and outreach, and is also a member of the board of directors of the American Physical Society. His legacy is his work on quantum entanglement has revolutionized our understanding of quantum mechanics and has paved the way for the development of new quantum technologies. You can check about quantum computing in the episode linked in the description. And finally, Anton Zeilinger. He is an Austrian quantum physicist and Nobel Laureate of 2022. He is professor of physics emeritus at the University of Vienna and senior scientist at the Institute for Quantum Optics and Quantum Information of the Austrian Academy of Sciences. Most of his research concerns the fundamental aspects and applications of quantum entanglement. Born in 1945 in Riedem Innkreis, Austria, he studied physics at the University of Vienna from 1963 to 1971. He received a doctorate in 1971 with a thesis on neutron depolarization measurements on a di-single crystal under Helmut Rauch. He qualified as a university lecturer at the Vienna University of Technology in 1979. Zeilinger's doctoral thesis focused on the development of new techniques for measuring neutron depolarization. This work helped to advance the field of neutron scattering, which is a powerful tool for studying the structure of materials. After completing his PhD, he worked as a postdoctoral researcher at MIT. He began to study the field of quantum entanglement and has made significant contributions to the field. He has developed new experimental methods for generating and manipulating entangled particles. He has also used entangled particles to perform a variety of groundbreaking experiments, including teleportation and quantum cryptography. In 1997, he and his colleagues conducted the first successful experiment in quantum teleportation. It is the process of transferring the quantum state of one particle to another particle, even if they are separated by a large distance. For detailed understanding, check out the podcast series called Quantum Bugs in our channel. He has given numerous public lectures and interviews about his work, and he has written several popular science articles. He is also a member of the board of directors of the European Physical Society. In next episode, we shall cover scientists who won the prize in 2021. Subscribe to never miss an update. Click here to know about those who received Nobel Prize in Physics in 2023.